Our lesson on 6.4 is going to continue on our use of the factoring method, so hopefully you have basic factoring under your belt, and we're going to start factoring some more complicated polynomials. So let's warm up a little bit. Remember, if you have a general trinomial, that means you're just going to kind of factor it by writing down your two sets of parentheses, and this is the type of problem where you sometimes had to guess and check and revise. So 2x squared would be a 2x and an x. And then you had to think of some ways to get a negative 12, so maybe you tried negative 6 and 2, negative 2 and 6, 4 and negative 3, negative 4 and 3, and eventually you'd settle on a plus 3 here and a negative 4 here. And the reason we knew that worked is when you did outer plus inner, you got a negative 8 plus 3 in the middle, which gave us our negative 5 in the middle. Now, a perfect square trinomial was sometimes you noticed a pattern because these first and last numbers were perfect squares. So that kind of made you think, oh, well, it's probably going to factor into something with the square roots. And turns out this guy factors into x plus 5 times x plus 5, or sometimes we wrote that as x plus 5 quantity squared. The difference of squares was my favorite pattern. That's where they were both perfect squares and very easy to factor because all you had to do was kind of square root the first and the last number. And you got 2x. One was a plus 3, and then 2x, the other one was a minus 3. And then the most basic type of factoring is just to look for common monomial factors, so something you can divide both of them by. Well, a 6 and a 15 are both divisible by a 3, and then the x squared and the x, they both can take out an x. And when you factor out the common factor of 3x, you're left with 2x plus 5. Even though it doesn't look so impressive, that is a form of factoring, and that's actually the first type of factoring you should look for. So here's how we're going to handle today. There's a couple patterns here in this box that we're going to be using shortly, but our first step in factoring is to factor out any common terms. So we're first going to look for that. And then if there aren't any, or if we've already done that, our next step is to determine whether you have 2 terms, 3 terms, or 4 terms. Well, if you have 2 terms, you're going to be one of these patterns. If you have 3 terms, we're just going to be normal factoring. And by normal factoring, I mean the kind where you just draw your 2 parentheses and you guess and check and revise. And then factor by grouping is a technique we haven't talked about yet, but you're really going to like it. So, the first problem says x to the third plus 27. Well, there's no common term, so there's nothing I can factor out. But I notice it is 2 terms big, so I have to decide whether it's the difference of squares pattern or whether it's a sum or difference of cubic pattern. Well, this is a sum of cubes, so the first thing I'm going to have you figure out or find is back a page. This is the pattern we're talking about, a to the third plus b to the third. So I'm going to go ahead and kind of write that above this because I don't have it in front of me. And the way I factor a to the third plus b to the third is I do a plus b times a squared minus ab plus b squared. Okay, so what I want you to do is figure out who is a and who is b. Well, if x to the third is a cubed, or a to the third, that means your plain old a would just be x. And if 27 is b to the third, that means plain old b would just be a 3. Basically, I cube rooted both of them. So taking those numbers and plugging them into my formula, it says a plus b, so I'm going to write down x plus 3, and then a squared, so x squared, minus a times b, so minus 3x, and then plus b squared would be plus 9. And what's nice about this pattern is once you fill it in, there's no more simplifying you can do. Can't factor anymore, can't take anything more out, we are done. Okay, number 2, I need to look for my common term first, and I notice that 16 and 250 can both be divided by a 2. And then the other thing I notice is I can take out u squared. So when I factor out a 2u squared, I end up with 8u to the third minus 125. Well, inside the parentheses, I have 2 terms, and it looks like they're not squares, but they are cubics. So this is the difference of 2 cubes pattern. So I'm going to write down that pattern above my problem because I don't have it on the screen. But the pattern on the box above this says a minus b times a squared plus ab plus b squared. And yes, you do have to memorize this pattern. Now, when I look at 8u to the third, he's my a to the third. I need to cube root that to find just plain old a. So the cube root of 8a to the third, or 8u to the third I should say, is 2u. And then 125 needs to be cube rooted, and that's how I would get a 5. Now I know you're probably inclined to write a negative 5 down, but the negative is part of the formula, so you don't have to worry about that at all. So my 2u squared stays out in front, and then when I go ahead and plug everything into the pattern says a minus b, so 2u minus 5, and then a squared. Be careful here, 2u squared would be 4u squared, plus a times b, so 10u, plus b squared, which would be a 25. And remember, this pattern can't go any further than once you get that to that point, so that's your final answer. I realize that seems a little complicated. It'll get better, I promise. Okay, number 3, there are no common terms. And since it's 2 terms, I have to decide whether it's squares or cubes. Well, I'm looking at my numbers and I'm thinking these are squares. So remember, the difference of squares is that really easy pattern where you just square root both of them. So the square root of the first and the square root of the last. So let's see, that would be 5x squared for the first. And then one's a plus 6 and one's a minus 6. Now you have to be a little careful in this lesson because sometimes this term will factor again if it's both another difference of squares. Since this one doesn't, we're done. Alright, this is the difference of squares pattern. Remember, the difference of squares was a cube, sorry, a minus b times a squared plus ab plus b squared. So my a value is just x, and my b value is the cube root of this, which is a 2. Don't worry about the negative, he's already in the formula. So using my pattern, I have x minus 2, and then x squared plus 2x plus 4. And again, with the cubic pattern, once you put it into the pattern, you are done. Okay, number 5, 2 terms, definitely not squared, so it must be a cubic pattern. So I need to identify that this is the difference pattern, which is a minus b times a squared plus ab plus b squared. Okay, so your a is the cube root of 27x to the third, which would be a 3x. And your b is the cube root of 1, which would be a 1. So plugging all that good information in, we're going to have a 3x minus a 1. Now be careful here. A squared would be 9x squared. A times b would be plus 3x. And then b squared would be a plus 1. Alright, number 6. We finally get to something with 4 terms. And it says when you have 4 terms, we're going to factor by grouping. I love factor by grouping. Grouping means we're going to group the first 2 together, and then we're going to group the last 2 together. And we're going to treat them like individual problems. So the first group, x to the third minus 2x squared, I have to factor out what's in common. So when I look at what's in common here, I think they have an x squared in common. And then when I factor out the x squared, you end up with x minus 2. Now we're going to do the same thing here in the last group, and I think about what's in common for a negative 5x and a plus 10. And I know you can see the 5 is in common, but because the first term is negative, I want you to also factor out a negative. So when I factor out a negative 5, I'm left with, interestingly enough, an x minus 2. Now you should notice that these match. That's how factor by grouping works. If the parentheses don't match, you either did it wrong or you're just not quite done yet. So what happens now is this problem has an x minus 2 in common. So what I'm going to do is I'm going to factor out the x minus 2 in front of the entire problem. So this is gone and this is gone. And that leaves us with the x squared minus 5. And I think we're done. Now, I warned you on another problem that sometimes this term is going to factor again if it's the difference of squares. Well, 5's not a perfect square, so don't worry about it. but sometimes it will show up where you factor another layer into this problem. Okay, I think number 7, we have another factor by grouping. So let's group the first two together, let's group the last two together. So my first group, I can factor out an x squared, and that leaves us with a 2x plus 3. And then in my last group, there's not much I can factor out besides maybe a negative 1. And that leaves me with, surprisingly enough, a 2x plus 3. Now, you've got a common factor of 2x plus 3 that we need to take out. So when I bring the 2x plus 3 in front of the entire problem, so this is gone and this is gone, we are left with an x squared minus 1. And this is what I was warning you about. X squared minus 1 is not completely factored yet. He can factor some more. So there's still a 2x plus 3, but the way we'd factor x squared minus 1, that's the difference of squares. So he's an x plus 1 and an x minus 1. And someone always asks me, well, what if I didn't do that step? Unfortunately, the answer is you got it wrong. So our next problem, group 1 and group 2. So we can factor out a common x first. We have a 2x plus 5. And then in our second group, I can factor out a positive 5. So we end up with, what do you know, a 2x plus 5. So we have a 2x plus 5 in common. So I'm going to factor him out in front of the whole problem. And once I take that out, I'm left with another x plus 5 off to the side. Okay, number 9. I think on number 9, we finally have a case where you have a common factor to take out. There's a common factor of x that you can take out of everybody, leaving you with x squared plus 3x minus 10. Now, in here you have 3 terms, and remember it says when you have 3 terms, your technique is just a normal factoring technique. So we're going to try to factor x squared plus 3x minus 10, and I think it factors pretty easily. I think it's going to be an x plus 5, and then an x minus 2, because that would multiply to negative 10 and add up to 3. So that problem is done. Okay, number 10, there's no common terms, and it's 2 terms. So I look at it and I try to figure out if it's cubed or squared, and it's obviously squared. So what we're going to do is we're going to square root both of them, and that's going to give us 4x squared plus 25, and then 4x squared minus 25. And again, I warned you that sometimes you have to factor twice in these problems. This is one of those cases. The 4x squared plus 25 we're just going to leave. However, the 4x squared minus 25 is another difference of squares pattern. So you have 2x plus 5 and then 2x minus 5. So this guy is your final answer. Okay, number 11. Looks like we have some like terms there. I've got a 4 and an x squared that I can take out. So when I take out a 4x squared, I'm left with x to the 4th minus 5x squared, and then plus 6. Now in the parentheses I've got a trinomial, so I got to think about factoring this like normal. But instead of just being x squared in the first term, it's x to the 4th this time. And all that means is we're going to have x squared and x squared. Now to multiply to a positive 6 and add up to a negative 5, I'm thinking we can do a minus 3 and a minus 2. Now luckily, nothing else factors because they weren't difference of squares. Sometimes you got to be careful. Sometimes one of these will be another difference of squares that you have to factor more. Okay, on number 12, I've got a common factor of 2 I can take out before I start, leaving me with x to the 3rd plus 64. Well, bummer. We kind of have one of those patterns. It's the cubic pattern. So remember, the a in this part would be just an x, and the b would be a 4. That's the cube root of 64. So I'm going to bring this down here. The 2 stays out in front, but using my sum of cubes pattern, we get a plus b, so x plus 4, and then x squared minus ab, so minus 4x, plus 16. And that is your final answer. that pattern is really not bad once you have it memorized. Okay, there's a common term in number 13. I can take out a 7 and an x, and when I do that, I'm left with x squared minus 100. Now we're not done, because x squared minus 100 is the difference of squares. So we can factor that into x plus 10, and then x minus 10. And now we are done with that problem. Okay, number 14, no common terms, but I do think we have a pattern, difference of cubes. So we're going to say who's A and who's B. Well, the A would be the cube root of 64x to the third, so that'd be 4x. And the B would be a 3. And remember, the negative is built into the pattern. So using our pattern, it says A minus B first. So 4x minus 3. And then a squared, careful, would be 16x squared plus a times b, which would be a 12x. And then plus b squared would be a 9. I like that pattern now that I have it memorized. It's pretty easy. Okay, here on number 15, we've got a common factor of 2 I need to take out first. And now x to the third plus 125, that's the sum of cubes. So a is going to be an x, and then the cube root of 125 is 5. So b is 5. So taking this down a little bit, the 2 stays out in front, and then if I use my sum pattern, oops, I'm going to run out of room. We have a plus b, so x plus 5, and then a squared minus ab plus b squared. And there's your final answer for 15. Okay, moving along. The next couple problems are all factored by grouping because there's 4 terms. So we've got our first group and then our second group. So our first group looks like we have an x squared we can take out. And that leaves us with, x plus 3. And then my second group, I can take out a positive 2. And that leaves me with x plus 3. Remember, if the parentheses don't match, you didn't do it right. So we've got our like terms of x plus 3 that we can take out of the whole problem. So it becomes x plus 3 in front, and then x squared plus 2, in the back. You could rearrange the order. If you flip these around, it would be fine, because that's a commutative property. Okay, my next problem, in my first group I can take out an x squared, and that gives me x minus 1. And then in my second group, I can take out a positive 4, which will leave me with, surprise, surprise, x minus 1. So our common term now is the x minus 1. And when I take that out, I'm left with an x squared plus 4. There's no difference of squares to continue the factoring, so we are done. Okay, our next problem is kind of strange. The first group, we're going to take out an x squared. And that leaves us with x plus 5. Now your second group, there's nothing to take out, but you have to factor something out. So we can always factor out a plus 1 if we're really stuck. And that just leaves me with my original x plus 5 inside the parentheses. So now when you take out the common term of x plus 5, you're left with x squared plus 1. Alright, 3 more. More factor by grouping. So our first group, we can take out an x squared, and when I do that, I'm left with x minus 2. And then in my second group, I can take out a positive 4, and that leaves me with x minus 2. So my common factor is x minus 2, and then I'm left with x squared plus 4. I double check that nothing can factor further, and nothing can, so we are done. Number 20, in my first group, it looks like I can factor out just an x squared, and that leaves me with a 2x minus 5. And then in my second group, I think I can factor out a positive 9, and that leaves me a 2x minus 5. So our common term that we're going to take out is a 2x minus 5, and we're left with an x squared plus 9. I double check that nothing can factor further, nothing can, so we are done. Okay, now kind of weird, this first group, I'm going to take out not just a 2x squared, but I'm going to take out a negative 2x squared, because mathematically people don't usually like when you have negatives in the first term. So when I factor out a negative 2x squared, I end up with positive x and then a positive 2. Now same kind of situation going on here in the second group. I'm going to factor out not just a 3 but a negative 3. And when I do that, I'm left with positive x and a plus 2. So now we've got an x plus 2 that I could take out in front, and then a negative 2x squared minus 3. Now that's a great answer for me, but your ACT would probably do one extra thing. They would take a negative out of this back term, the set of terms. So they would factor a negative way out in front of the whole problem, and then not change anything other than the signs of that back problem. So they would become a positive 2x squared plus 3. So either one of these answers are absolutely perfect. I'm just thinking the ACT would probably opt for this example rather than having all the negatives in the binomial on the end. So that concludes our lesson for 6.4. I know it is a lot to take in. You really need to practice this one. So if you have any questions, come in and see me.